Okay, so for question 5, we're going to try a slightly different tack, and that is I'm going to run through all the questions to see how we would try and solve them, and then we'll go into each one. So we're given two graphs, a parabola. Now it's a sad parabola because of this negative here. A straight line, looks like a positive straight line going up. Okay, so they're given below, and we've got these 6 questions. So let's just see what they're asking and how we're going to answer them. Determine the coordinates of the turning point D. Okay, so how do we find out what the turning point of a parabola is? Well, we know that that's going to be PQ. So if we can turn this into turning point form, x minus p squared plus q, we've got our answer. And hopefully we know how we're going to change that into turning point form. Yeah, right? P equals minus b over 2a, and for q we're just going to substitute it into this original equation that we're given, so f of p. In other words, sub in whatever value we get for p into here, and we'll get the output. I mean, it fits in with our function knowledge. To find the output, input the input. Okay, so we can find out d. Determine the length of AB. Okay, what's special about points A and B? Well, they're just the x-intercepts of our parabola. And in fact, A is the x-intercept of our straight line. So if we can just work out the x-intercepts of the parabola, or work out the x-intercept of our straight line, or I'll show you another way, just because it's worthwhile knowing and just keeping on deepening our knowledge of parabolas. And the other way I'm going to say is, well, we already know what the middle point of this parabola is, because we know this is going to be p. We're going to work out what it's going to be, and its y value is 0. So if we can find out this x-intercept quite easily, this distance is the same as this distance. So if we can work out the x-intercept of the straight line easier, which definitely is easier than working it out for the parabola, then if that distance comes out, I don't know what it's going to be, but let's say it's 3 or 4, and let's say that it's 3. If that distance is 3, that distance must also be 3, because the parabola is symmetrical. And it's worthwhile just deepening that knowledge instead of just going, well, let's let y equals 0 and find out those two x-intercepts. Perfectly valid. We'll definitely get the same answer. Okay, so that's B we know how to do. For C, determine the length of EF. EF. Okay, so what's special about points E and F? Well, point E, it's on the y-axis, so it's just the y-intercept of the parabola. Well, that's easy. We're going to substitute x equals 0, and I'm going to jump ahead and just say I know what that's going to be, 24. And for F, it's just the y-intercept of the straight line. And again, if we substitute x equals 0 into here, we know that 4 is going to be the y value of the y-intercept. So we actually know that that's going to be 20. It's probably the easiest question out of all of them. Determine the coordinates of C. That's what they want in question C. Let's check. Oh, I learned a new trick. Okay. Determine the coordinates of C. Okay, so C is sitting over here. What's special about C? That's where the two graphs are equal to each other. So if we just put the parabola, that equation, equal to the equation of the straight line, then we should get there, because it's just asking where they're equal to each other. Now one solution will be down here. It will be A. We've already worked out that coordinate, so we will get two solutions, and we know that it must be this one. Also, it's going to be the positive x value, not the negative. Okay. Determine the length of PQ if OR equals 3. So where is PQ if OR? R is this point here. Let's just rub this little thing out for now. Well, if OR is 3, then we know, we've been through some of these types of questions, then the x value is 3. So in other words, if we can work out for P, we know the x value is 3. We're going to work out the y value. For Q, we know that the x value is 3, and we're going to work out the y value, and then we're just going to subtract. So if it's like 10 and 4, then it's going to be 10 minus 4 is 6, whatever it is. It's definitely not 10 and 4 though, because there's 4. Okay, then for our last question, for which values of x is g of x greater than f of x? So when is g of x, when's the straight line greater than, so in other words, when is it above the parabola? Well, let's just go left to right and let's highlight it. So when's the straight line above the parabola? Is it above here? Yeah, it is. So that's going to be part of it. Straight line. Nope, it looks below. You can see the straight line sitting below the parabola for this bit here. Okay, and then we go along here, and from this point, it's going to be above the parabola again. So in other words, we just need to work out these values a, so whatever a is, it's going to be left of that, and the other option is going to be when it's greater than, so when it's left of a, really rough terminology or how I'm writing it here, or when is it right of c. Okay, so there's how we're going to solve each of those questions. So yeah, hopefully that gets you there. But let's run through them and actually solve them. Also means we've got nice full solutions in our notes here. Okay, so let's start. Determine the coordinates of D, the turning point. Okay, for turning point, I'm going to go more quickly now because we've gone through how we're going to do this. P equals minus B over 2A. So for A, P equals minus B over 2A, which is B is 10, so minus 10 over 2A. A was here, negative 1. So that's negative 1. So we got negative 10 divided by negative 2 gives us positive 5. So in other words, our equation so far looks like y equals A. Well, we know what A is. And a few of you are doing this, and I like this. You're saying, well, A is minus 1, B is 10, and C is 24. So y equals A. A is minus 1. X minus P, so minus 5 squared plus Q. Don't know what Q is yet, but as I said, I was actually picking this up from your work. You're writing down this bit so long instead of jumping ahead and then going, okay, well, what is Q? Q is f of P. In other words, if 5 is the input, so we can rub that out and replace that with 5. What's our output going to be? Well, f of 5 is, where's our equation? Minus x squared plus 10x plus 24. And we get our calculator out to our calculator emulator, and we go minus, and be very careful here because the minus is outside of that bracket. So minus 5 squared is going to be minus 25 plus 10 times 5 plus 24, and we get 49. Okay, so Q equals 49. So y equals minus 1. Could just have it as minus, but I actually like that minus 1. Minus 1 x minus 5 squared plus 49. You know, I'm a big fan of this. Place that, put it in our diagram in case we need it. 49, we know that this is 24, that's 49. Sort of matches the picture. Remember, not to scale, but definitely 49 is bigger than 24. Okay, so there we go. What did it really ask though? Determine the coordinates of turning point D. We've written in our diagram. Let's just write it here as well. But to be completely honest with you, it's in the diagram. You're getting your marks because I can see it in the diagram. But put it down here because it's nice to follow through the working and see it here. Okay, so we've got our turning point. What's the length of AB? So what we're saying is AB is just, if you can work out the x coordinates, then we can work out this distance. I said, let's look at this in a more interesting way. Said if we can work out what this distance here is, then we can just double it. And we know what P is. We know that we've worked this out to be 5 and 0. So if we can work out whatever this distance is, then that distance must be the same because the parabola is symmetrical about this line. Maybe that's why they've drawn this line down here, just to hint us at that way of working it out. So let's work out the x-intercept of the straight line because it's the same as one of the x-intercepts of the parabola. So our straight line is y equals 2x plus 4. 2x plus 4. And we're asking ourselves, when y is 0, what is x? Well, 2 times what plus 4 gives us 0. X must surely be minus 2. We could have gone minus 4 and then divided both sides by 2. So in other words, what we've worked out is that a has the value minus 2. That's ugly, minus 2, 0. Okay, so if that's minus 2, 0, and this point's 5, what's this green distance between a and this middle bit? Well, minus 2 to 5 from my calculation gets me about 7. So if that distance is 7, this distance must be 7 as well. So if that was sitting at x equals 5 and we're adding 7, then this distance here is 12. If you can see that, definitely feels a lot quicker and easier than having solved the quadratic. Except, of course, that you would have just put it into your quadratic formula and you would have got your two solutions, minus 2 and 12, or you would have factorized and it would have factorized quite nicely. So it's not a huge saver, but a useful one, I think. Okay, so there we go. That's what A is, but it said what's the distance, excuse the scrolling, AB. So from A to B, well, if that's distance is 2 and that distance is 12, whole distance must be 14. Or we could have said 12 minus minus 2. Okay, but AB equals 14. 7 and 7. Guess we could have done it that way as well because we had those in our diagram. Cool, looking good. C. I wanted that sense of accomplishment. Tick, I've done that. Tick, we've done that. Determine the length of EF. EF. Well, we kind of did this one already. 24 minus 4 is 20. Done. Let's scribble it in here because we can always go to that side. C, E, F equals 20. And we've shown our working in the diagram here. We've written 24 and 4, so it's clear where we got that 20 from. Now you could write 24 minus 4 over here equals, but we've shown it. Okay, determine the coordinates of C. What did we say was special about C? Oh yeah, C is where the straight line is equal to the parabola. Now, there's nothing to say that don't tell us that this is exactly the same y value. That would be really handy. I can't see how we would know that C has the same y value. It might not as E, otherwise it would be easy. We could put 24 and just sub it into one of them. But let's just make our two graphs equal to each other. Now I'm going to move over to the right here because simultaneous equations always just take a bit of time. So we're saying, let's do it like this. When is f of x equal to g of x? It's nice to put that opening line, shows what we're doing. So when is minus x squared plus 10x plus 24, when is it equal to 2x plus 4? Okay, I'm going to rearrange, make my positive x squared here. So x squared, I've got 2x minus 10x gives me minus 8x, 4 minus 24 minus 20 equals 0. Okay, must have two values for x. We know what one of those values is going to be. Must be down here at A. That must be out where they equal to each other. And just squeeze in there. Okay, so one of our values must be at A. This is one of our answers. So I already know that one of them must be x plus 2, so that x equals minus 2 as a solution. Okay, nice little cheat just to make the factorization easier. Keep saying this. Useful to remember, of course, just use the quadratic formula when you want to. You're getting so quick and comfy with it. I can see from your work. You're just going, here we go, did it on quadratic formula and you're in. Okay, plus 2 must mean that x minus 10 plus 2 minus 10 minus 8, so it works. So, or x equals 10. Okay, we're going to pick this one over here because this one related to A. So for this one, fill in the diagram over here. Now we need to work out the output. Given the input, how to work out the output, just sub into the equation. So I'm going to sub into G because, you know, a lot easier subbing into a straight line. So 2 times 10 plus 4 equals 24. Okay, so that's our y value, so 24. So therefore, we know that our point, which is C, is 10, 24. I'm really looking at this, and I may well be missing something. That is 24. It has lined up directly in line with E. But we know that's 7, that must be 5. That was 5 to that point. I can't see how we would know directly without putting these two graphs equal to each other. Maybe it's just worked out quite nicely. And the umming and ahhing here is why this has got the same y value, why E and C are in line. Okay, can't quite see why it's definitely the case, so we can't use it. Okay, so we found out that. Determine the length of PQ if OR equals 3. We've done a few of these. I find them overly complicated for what we're doing, which is just we're trying to find PQ. We're given the input is 3, so we can work out the output by subbing. We're given the input is 3, we can work out the output by subbing. So we can just go for P is sitting on F, so we can go, this is to do with P. F of 3 equals minus 3, oh, that looks like square root 3, minus 3 squared plus 10x plus 24 plus 10x plus 24. And let's scroll down so that it's visible. Okay, might as well just calculate it up. Minus 9 plus 30 is 21, plus 24 is 45, right? Always worthwhile. Let's just check it. Minus 3 squared plus 10 times 3 plus 24, 45 it is. So we know that point P is 345. It's captured in our diagram straight away. 345. As I said, diagram not to scale, but definitely 45 is lower and less than 49. Okay, for the straight line, 2x plus 4, y equals 2x plus 4. So this is for the other point, point Q. So this is Q that we're working on. So that's 10. So Q is 310. Therefore, PQ is 10 up to 45 must be 35. 310. Okay. Cool. Last question. For which values of x is g of x greater than f of x? So what we were saying here at the beginning was, when is the straight line above the parabola? So whenever these, remember, our y values. So when our y value is above, well, anything less than a and anything greater than c. We know what these values are, minus 2 and 10. So we're going to say when x is less than minus 2, or when x is greater than 10. That's when it's going to be above. And let's just leave that for a second. That's it. There are questions. Hopefully by now you're getting into the swing of it. Each one, just break it down and go from there.